Welcome, boys. We were doing salts, and through our previous class, we have learned about the definition of salt and different types of salts. Now, in today's lesson, we are going to see few preparations of insoluble salts, few different types of preparation. Among the different types of preparation, we will focus on a direct combination first. The direct combination method, or this is also called synthesis method. Why this is called synthesis or direct combination? Because in this particular type of reaction, the salt, the components of the salt are directly reacted with each other. For example, let's take this example of lead sulfide. Now, if you see over here, this is a salt, lead sulfide, and it contains lead and sulfur. So these lead and sulfur are the components of the salt. Therefore, if these components are directly reacted with each other, lead plus sulfur, and when they are heated, this will combine with each other to give the resultant salt. In the same way, iron sulfide is salt. Therefore, the components of salt are iron and sulfur. So if iron and sulfur are reacted with each other by heating, then they will combine to form iron sulfide salt. So this type of method where the components of the salt are directly reacted with each other under various conditions are known as direct combination reaction or synthesis reaction. Now, in this synthesis reaction, we are going to particularly focus on the laboratory preparation of some salt, especially iron chloride. Now, let us see the laboratory preparation of iron chloride, that is ferric chloride, FeCl3. Now, this is also a synthesis or direct combination method. Why it is a direct combination method? Because iron 3 chloride or ferric chloride contains iron and chlorine as the component elements of the salt, and therefore in this method we are going to treat directly iron with chlorine. So let us see the procedure first. So in the laboratory we have to have this type of arrangement of the apparatus. This is called Holmes bottle. This is a combustion tube. This is a conical flask fitted with delivery tubes in this way. And over here we have the different substances which we take are, first we have to take chlorine and we have to take iron, because these are the two components of the salt iron 3 chloride. Now, apart from these two components, we also take concentrated sulfuric acid to dry chlorine gas, because over here we don't want chlorine with any moisture, and we all know concentrated sulfuric acid is a good drying agent. So when we pass this chlorine through concentrated sulfuric acid, chlorine becomes dry. We also take fused calcium chloride in order to, again, also as a drying agent, in order to absorb all the moisture if there are any produced as a result of this reaction. Now the procedure is, we have to take iron wire or iron powder inside the combustion tube. It has to be heated first. So initially the iron wire is heated, so here the temperature will be already high in the initial process. Now when the temperature is high over here, now we have to pass chlorine gas through this delivery tube through concentrated sulfuric acid, so that all the moisture gets absorbed, and the chlorine gas which comes out and passes through this delivery tube and enters the combustion tube is very dry. Therefore, the dry chlorine gas, when it enters in the combustion tube, now over here chlorine will react with iron at the higher temperature due to earlier ignition of the wire. Now, since the reaction of iron and chlorine is an exothermic reaction, now heat will be produced. Once the reaction starts, heat will be generated. Now when heat is generated, now the heating of the coil is stopped because heat is already being provided by the reaction itself. So once the reaction starts, heat gets produced, and that heat produced will continue the further reaction and lead to the completion of the direct combination of chlorine and iron inside the combustion tube. Now once iron and chlorine reacts over here, the product form will be iron 3 chloride. Now that iron 3 chloride in the form of gas passes through this delivery tube and enters over here, and finally it gets condensed into a brown scale or brown colored solid product called solid iron chloride. Now here fused calcium chloride helps to absorb any moisture or any water present in the conical flask, so that the solid iron chloride doesn't combine with water, doesn't dissolve in water, because iron 3 chloride is highly deliquescent substance. It will absorb water. The chemical reaction involved in this preparation of iron 3 chloride is iron 2Fe plus 3Cl2 chlorine. When heated, it turns into ferric chloride 2FeCl3. Remember, the iron has to be in heated condition first. Then the chlorine required to carry this experiment has to be dry. And finally, ferric chloride, which we get as a product, has to be collected in solid form. Therefore, to stop iron 3 chloride dissolving in water, what do we use? Drying agent, calcium chloride. Now in this particular lab preparation of iron 3 chloride, we have to take some important precautions, and those are: the chlorine gas which we use to carry this reaction has to be dry. And what helps to dry chlorine gas? Concentrated sulfuric acid. Why? Because concentrated sulfuric acid is a good drying agent. Second condition, the iron has to be heated first. It has to be in a heated condition. Third, we have to use fused calcium chloride. Why? To stop iron dissolve in water, because iron 3 chloride is a deliquescent substance. It absorbs moisture and dissolves in it. So these are the important points which we have to remember in the laboratory preparation of iron 3 chloride. The process of preparation of iron 3 chloride is synthesis or direct combination. The elements which we require to carry this particular reaction: dry chlorine and heated iron. And what are the drying agents we use? Concentrated sulfuric acid and calcium chloride. Why we use calcium chloride? Because iron 3 chloride is a deliquescent substance, so it will absorb moisture and dissolve in it. So to stop the iron 3 chloride dissolve in water, we use calcium chloride. And finally, we have to remember the chemical equation of this particular reaction. Now, another method by which salt can be produced is by displacement reaction or by displacement method. And we know, to understand displacement reaction, we have to remember the activity series of metals, which we learn in class 9, and that will be applicable in class 10 also, and even in higher studies. So therefore, please look at the activity series of metals. Please revise it and make sure that you know all the metals according to their correct position in the activity series of metals. So if you know the activity series of metal, then to understand this type of preparation becomes very, very easy for you. Now let us see the one example: formation of zinc sulfate salt, which is also called white vitriol. Now in this particular preparation, what we need: zinc. It is a salt of zinc, and the anion of salt is sulfate. So we need zinc as one of the reactants and another reactant which is a compound of sulfate. So zinc we take, and we take sulfuric acid because sulfuric acid has sulfate anion. Now according to activity series, zinc is placed at higher position compared to hydrogen. Here we have two cations, zinc and hydrogen. Now zinc being at the higher position in activity series, zinc is more reactive than hydrogen. So those metals which are more reactive than hydrogen or at higher position in the activity series will remove or displace hydrogen from its compound. So what this zinc will do? Zinc will displace or remove hydrogen from the compound sulfuric acid, and as a result zinc will take the place of hydrogen. Hence zinc will combine with sulfate, and this is the salt, required salt, zinc sulfate. Now hydrogen is removed from the compound, so we will get hydrogen gas. So this is called displacement reaction. So by displacement reaction we can also make required salts. Example is zinc reacts with sulfuric acid to form zinc sulfate and hydrogen gas. There are other reactions given in the book. You can go through them one by one. Another method which we are going to understand today is by double decomposition or precipitation. Double decomposition means a reaction in which two different compounds they react. When they react with each other, they exchange their radicals or ions and give completely new products, two new products. Two compounds react with each other, they exchange their ions and they form two new products. And one of the product formed will be, if it is insoluble, then that particular insoluble solid substance is called precipitate. So we are going to see double decomposition reaction of precipitation type. So let's see one example, that is preparation of lead chloride. Calcium chloride, it is there in the book. You can refer to the preparation of calcium chloride in the book. Let's see first lead chloride, preparation of lead chloride. So in order to form lead chloride, now please look at this particular salt. We have lead and chlorine as the constituent of this salt, lead chloride. So we have to take two reactants, one containing lead and other containing chlorine. So those two reactants are lead nitrate and hydrochloric acid. Now over here this is positively charged radical or ion, and here this is positively charged radical or ion. Now double decomposition reaction means they will interchange their ion. So lead, when they are brought together, this lead will be changed over here, it will go over here, and this hydrogen will take the place of lead. So this is called interchange of ions. So when these ions interchange their places, now lead will combine with chlorine, so lead chloride will be formed, and this is insoluble solid which does not dissolve in the solution. And the another product which will be formed will be hydrogen combines with nitrate, so nitric acid will be formed. So this type of reactions are called double decomposition reaction because they are interchanging, the two reactants are interchanging their ions. And in double decomposition reaction also, this is a type of reaction where precipitate is formed. Precipitate means insoluble solid substance produced as a product. So since lead chloride does not dissolve in the solution, it remains as solid and settles down at the bottom, and therefore this is a precipitate, and this is precipitation double decomposition reaction. So this is the required salt which we need, lead chloride. So this is an example of the method of preparation of salt, that is double decomposition precipitation reaction. Now you can also refer double decomposition reaction method for the preparation of calcium chloride in the same way. Now another method of preparation is neutralization reaction. Now this is also double decomposition reaction. Neutralization reaction is also a type of double decomposition reaction, and we all know what we mean by neutralization reaction. Neutralization reaction is a reaction in which acids react with bases to form salt and water. So let's see one example. Let's take base sodium hydroxide and acid as hydrochloric acid, HCl. Now here sodium is cation and over here hydrogen is cation. Now it is a double decomposition reaction, so they will exchange their ions. So sodium will come over here, take the place of hydrogen. So when sodium comes and takes the place of hydrogen, it will form sodium chloride. This is a salt. Now hydrogen will take the place of sodium and therefore it will form water, H2O. So this is another method for the preparation of salt, and that method is neutralization reaction. So this much for today, boys. I want you to go through this method of preparation of salt chart. Try to understand different methods by which salt can be prepared. And in our next class, when we come back for our next class, I will help you how to convert one particular type of salt to another type of salt. We'll take some important tips to understand how to convert one type of salt to another type of salt in our next class. So this much for today, boys. Stay safe and do all things well.